Hey everybody, happy Tuesday or Wednesday, whenever it is that you're watching this video. Let's go ahead and get into today's lesson. If you are watching this on Tuesday night, you will have not yet learned about vital information. If you're watching this on Wednesday in class, maybe you already did hear about the vital information. But this is what you need to know. If our function is an x to the even graph, the end behavior is up and up. Sometimes we draw arrows and show up and up. Some people prefer to say up and up. A good example of this, x to the even, would be like x squared. Positive x squared goes like this. The end behavior is up and up. Well, if positive x squared or positive x to the even is up and up, negative x to the even would be like a negative x squared graph, which would be down and down. So you could draw arrows pointing down, or you could literally say the words down, down. When I think of an x to the odd, I tend to think of positive x cubed, which I know goes like this. So we say for that, we say that the end behavior is down and up. So down in this way, up in this way. And negative x to the odd would be the exact opposite of that if everything was reflected over the x-axis. So instead of being down and up, it's up and down. And I know it's awkward sometimes seeing the examples before you see the concept explained, but I will explain this in class on Wednesday as to why up, up, down, 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 up, down. At the end of the day, this is just information that needs to be memorized if it doesn't make common sense knowledge to you. Now we would use this information to fill in a chart like this. Complete the chart. Yay. So for this one, they give us some polynomials, and we need to say what the degree of the function is, which we learned about in class on Friday. We got to figure out the leading coefficient, the number that's hanging out with the main degree, and then what the end behavior is. Now, don't be fooled. When you look at this, you might think, 8x squared, this is a second degree polynomial, but you got to look for the biggest exponent out there, and in this case, it's the 4x to the 10. So that means this is a 10th degree polynomial because the 10th degree is the biggest degree on these. The leading coefficient, the number that's hanging out with the x to the 10 is a 4. So the leading coefficient is 4. The end behavior, it's positive x to the 10. So it's positive x to the even. And we learned from our chart earlier on, positive x to the even is up and up. So the end behavior is up and up. If you use words, you would write that. If you're using pictures, you would want to draw two upward pictures. Some people answer this way. Some people answer that way. Some people answer both. It's all good. Number 2, you look for the biggest exponent. Where is it hidden? And in this case, it's right here, negative 8x to the 5, because the 5 is the largest exponent. Because that's the largest exponent, that makes this a 5th degree polynomial. The leading coefficient is the number that's hanging out with that x to the 5, which is negative 8. So, at the end of the day, when you think end behavior, it's negative x to the odd. And a negative x to the odd has an end behavior of up and down. So you could either draw an up arrow and a down arrow, or you could simply write the words up, down. Either way, whichever makes most sense to you. Example 3. I need to get a piece of scratch paper for this one because this one has a little bit more involved. And I have to say, I'm just going to tell you right now, I'm going to put a little star by this problem because in previous years, people did fine with numbers 1 and 2 on quizzes and tests. When it got to numbers 3 and 4, they started getting them wrong. And let me show you why. On number 3, when it's written like this, you could view it as 2x plus 3 times 2x plus 3 times 2x plus 3 times 2x plus 3 times, that's 4 of them, x to the 4, plus x plus 3. There's 3 x plus 3's according to this. X plus 3. So, the first term, the leading coefficient, is going to come from going 2x times 2x times 2x times 2x times x times x times x. Now, I don't normally write all of this out. I just think of it this way, that the 2x, or this leading coefficient here, this little leading coefficient, the 2x is being raised to the 4th power, and then the leading coefficient for these three, the single x, is being raised to the 3rd power. So 2x to the 4, 2 to the 4, and x to the 4, that works to be 16x to the 4 times x to x times x times x. That's just x cubed. And this works out to be 16x to the 7. So what this tells you is that if you were to multiply all of these things out, because we just multiplied all of the leading coefficients together, we know that it would be y equals 16x to the 7 plus probably something x to the 6 plus something else x to the 5 plus something different x to the 4 plus something even different x cubed, and then an x squared, and then an x, and then just some number with the x, and then just some number on the end. It would work out to be this, but at the end of the day, we really only care about the 16x to the 7, and that gives us all the information we need. That tells us that this is a 7th degree polynomial. The leading coefficient was 16, and the end behavior, it's positive x to the 7, so positive x to the odd. And what we know about x to the odd is down and then up. Down and up. So I could draw a down arrow, or I could put an up arrow. I could also write the words down and up. Either one of these would work. Last one. Now, same thing. I'm going to do the same thing with this one that I did with the previous one, except I'm not going to show this step that I multiplied everything out. This was example 3. On example 4, I have this -2 out front, so I know that that -2 is going to be part of it. And then this x, this leading coefficient, is being raised to the 5th power. So I have x to the 5th power. And then the 3x on the end, this leading coefficient, is being raised to the 3rd power. So 3x to the 3rd power. This works out to be -2 times x to the 5 times 27x cubed. Excuse me. And then if I multiply this out, I get -54, -2 times 27, and then x to the 5 times x to the 3 is x to the 8. So I don't know what this, what all of this stuff completely works out to be, but I do know that it's going to get started with a -54 x to the 8, and then plus something x to the 7, plus something x to the 6, and so on. So using that knowledge, it was sorry about this, I'm a little sloppy here, my presentation. The -54x to the 8, that is a degree, it's x to the 8, so it's a degree, it's an 8th degree polynomial. The leading coefficient would be -54, which means this is -x to the even. And we learned from -x earlier that -x to the even is a down and down situation, just like -x squared is down and down. Okay, so that's how you deal with that's how you deal with problems, just to figure out the degree and the leading coefficient that lets you know about the end behavior. You need to know the end behavior if you're going to be graphing polynomials, and this is how you'd go about figuring out that end behavior. All right, let's get into our first, here's some information. Let's build a polynomial. So this is part 3. And in part 3, write an equation when f of x has roots, that's zeros, roots at x equals -3, x equals 2, and x equals 4, and passes, no, I'm sorry, it doesn't say it like that. And then it also says, and f of 5 is equal to 6. Okay, so write an equation when f of x has roots -3, +2, +4, and it passes through this point. This problem is a lot like when we did this last chapter, and we were trying to get an equation into factored form. There's this a out front that we got to figure out what the a is. Because of the root at -3, it's x plus 3. Because of the root at 2, it's x minus 2. And then because of the root at 4, it's x minus 4. And then we're going to use the point that the graph passes through to help us find the a. So when y is equal to 6, x is equal to 5. So I have 5 plus 3, 5 minus 2, and 5 minus 4. This becomes a times 8 times 3 times 1. 8 times 3 times 1, that's 24. So I have 24a. And then to finish solving for a, you divide both sides by 24, and you end up getting an answer of a is equal to 1/4. That means that our final equation is y equals 1/4 times x plus 3, x minus 2, and x minus 4. Just like a factored form problem, it's just because there's more zeros, there's a little bit more meat to the problem. Okay, that's all I have for you with this one. I guess the one thing I could continue on further is that if I then had to figure out, going back to part A, where did part A go? Oh, it's right here. If I then wanted to figure out the degree, the leading coefficient, and the end behavior, well, it's x times x times x, so it's third degree. The leading coefficient, x times x times x times 1/4 is 1/4, so the leading coefficient would be 1/4, positive 1/4, which ultimately means the end behavior would be positive x to the odd, so it ended up having end behavior like this one. So that's information we're going to use in a couple days in order to get these equations graphed. And everybody, that's all I have for you today. I hope you're having yourself a great Tuesday night or a happy Wednesday day in class. And if you have any questions about this lesson, stop the lesson, ask Elliot, let him answer that question, and then move on with your life. Have a great day, and I'll talk to you soon. Bye-bye.